this?
Yes, sir. Yes, sir. Now what?
Okay, now. This is a circle, and
Yes.
here is the center of the circle. Suppose here. So now, if I am making this circle arc, so what I am doing, I am just cutting this from the circle. So remember that the center of the arc is the center of the circle, of which the arc is a part. Okay, so from this arc, for this arc, we will just calculate the magnetic field at the center. Very simple. This is a derivation, and this derivation you can get in your exam also. And also remember that now the radius of the circle will be the radius of the arc,
Yes, sir.
and this is r is the radius of. So this is a circular wire. This is a wire in the form of the arc, and in this arc, the current is flowing in this direction. I current is flowing in this direction, and we have to find the magnetic field. We have to find the magnetic field at this point O, means at the center point. So what we will do? We will just apply the Biot-Savart law. We will apply the Biot-Savart law, and with the help of
Yes, sir.
Biot-Savart law, we will just calculate the magnetic field. So see how I will calculate the magnetic field. So here we already know that with the help of Biot-Savart law, we can only calculate the magnetic field due to the very small element of the wire. So first we will take very small element of the wire. Suppose this element of the wire I have taken. Very small element of the wire DL I have taken.
Yes, sir.
Okay. And the direction of this DL is in this direction. Okay. The direction of DL is in the tangential direction. Okay. And this radius, this is the radius of this circular arc, and this R radius and this DL are perpendicular. Okay. Both are perpendicular. Yes. So this angle you will say will be 90 degree. This angle will be 90 degree, you will say.
Yes, sir.
And this wire is, suppose I am giving it a name AB. So this wire is AB, and AB length I am supposing is L. And there is a one relation that you should know. Arc length you want to find.
Yes, sir.
You will multiply the angle subtended by the arc, that is alpha at the center. This is the angle subtended by the arc at the center, and
yes, sir,
with radius. Okay, you will multiply this alpha with radius. So arc length you will get, and this will come alpha into r. This is your equation number 1. So this is simple mathematics. Okay. So why I have calculated this arc length, you will get to know when I will move forward. So now, Harsh, we have this
yes,
current element. We have the current is in the wire, and this is the small element. And due to this small element, I want to find the magnetic field at this point O. So what I will do, I will apply Biot-Savart law. What is Biot-Savart law? For the small element, dV is equal to IDL.
IDL.
Sine theta. My cursor.
So it's mu 0 by 4 pi IDL sine theta by
Yeah, I know that. Just a minute. What happened? Okay, just wait. So it is mu 0 by 4 pi I dl sine theta divided by
r square.
R square. Okay, so this is the thing. So due to this small element dl, so right here, due to small element dl, dv is the magnetic field at O. So you are just calculating this dv. So now mu naught upon 4 pi will remain same. Okay, now we have I current, and dl we have, what is sine theta? Sine 90 we will take.
Yes, sir.
What is the angle between r, and this is the small r that you have taken. Actually, there is some problem in my system. Wait, what is happening? Just a minute. Harsh. Just
Yes,
wait a
sir.
minute. Please don't leave the meeting, okay? I'm just
No, sir. No, sir.
I have to restart it again.
Okay.
So, Harsh, please wait. Actually, my system is not working properly, so I'm just have to restart it again.
Okay, sir. So I'll leave the meeting and I'll join again. Yes.
Yeah, yeah, yeah.
Okay.
circular arc. It has wasted 15. Okay, so this is a circular. I have told you na. This is a circular arc. This is a small
Yes, sir.
element
Yes,
dl,
sir.
and we have to
Yes.
calculate the magnetic field at this point O. Okay.
Yes.
So theta, you will take 90 degree because the angle between this dl and this r is 90
It's
degree. You will
90
take
degree.
this.
Yes.
You will take, and r square. For the r square, you will take r square. This capital R square you will take. When you will solve it, you will get dv is equal to mu naught divided by 4 pi, and this will become IDL only.
Yes, sir. Right.
IDL only, because sin 90 is 0, sin 90 is 1. Okay.
Yeah.
Sin 90 is equal to 1. IDL divided by R square. So now now for calculating the total electric field, at this point, what we will do, we will integrate this equation. We will integrate this expression. Okay.
Yes, sir.
So what actually we are doing now? We are just taking a small element of this arc, and from these small element of the arc, we are just calculating the electric field, magnetic field at this point O, and we are just adding these. Okay. We
Yes,
are
sir.
just adding these. Okay? And this addition can be done by the integration. So integrating both sides. Okay. And this magnetic field will become total magnetic field at point B, at point O. So I am supposing V is the total magnetic field at point O, and out of the integration we can take the constant terms. So what are the
Yes, sir.
constant terms? This mu
Mu
naught divided by
0 4 pi. Mu 0 by 4
4 pi
pi.
is 4 pi is constant. This R square is constant, and I is
Yes.
constant.
Constant.
So mu naught divided by 4 pi is constant, and this I divided by R square is constant, and this is the integration of dl. And integration of dl means this total length. Integration of dl means you are taking a small element of the length, and finally you are adding this and these elements from A to B. Means you will get whole length A to B L. Okay, you
Yes,
will
sir.
get whole length L. So V finally you will get mu naught divided by 4 pi. This is I divided by R square, and this is L. And L, I have told you, L is equal to alpha R. L can be written as alpha R. Okay. So instead of L, now you will put alpha R. So this is I divided by R square. L is equal to alpha R, and 1 R and this 1 R is cancelled out. So finally your magnetic field will be mu naught divided by 4 pi I alpha divided by R. So this is your final formula. This is your final formula for the magnetic field at the
Magnetic field.
center,
Sir,
at the
of the circular
center of
arc.
circular arc. Please remember this magnetic field is at the center. Okay.
Yes, sir.
So
Yes. Okay.
suppose this arc has the n number of turns. Okay. If arc has n number of turns, arc have n number of turns, n number, capital N number of turns, then simply you will calculate the magnetic field at the center by multiplying this n. Okay, so this will become ni alpha divided by r. So this is the formula you will get. Please note it down. Then we will
Yes, sir.
discuss. How to find the direction. How to find the
Okay.
direction in case of this type of wire.
Yes, sir.
I'm zooming it out. Okay, now you can note it down. Now we have two more cases. We have one circle. We will calculate the magnetic field at the center of circular coil, and then
Yes,
we
sir.
will calculate the magnetic field at the center of semicircular coil. And those results we will derive using this formula, the formula
Okay.
that we are getting here. So just please note it down. After that, we will discuss that. Our 15 minutes, I think 20 minutes, not 20, 25 minutes are wasted, I think, today.
Yeah. Yes, sir.
Means 10 minutes uh, there means, okay, no problem. We can manage it.
ঠিক আছে পড়লাম।
Yeah. Did it completed?
Sir, just last part.
Okay. Okay.
Done, sir.
Done. Very good. So this is the case of the magnetic field at the center of the circular coil, and you should know this result. You should
Yes,
know
sir.
this result. So now, talking about the direction, uh, initially you have the straight wire. For the straight wire, you are using the right hand thumb rule. Now you
Yes,
will
sir.
use, for the direction of this kind of wire, for the direction of the magnetic field, you will use modified right hand thumb rule. So modified right hand thumb rule. So modified right hand thumb rule. First, we will write the definition. According to this, curl your fingers. Curl your fingers along the sense of current. Along the sense of current. Then thumb will give you the direction of magnetic field. Give you the direction of magnetic field. Now you have the circular arc here. Now you have this circular arc here. Just see this circular arc. Okay. Now, what do you have to do now? Just see. What you have to do this time, you have to take your right hand and you will curl your right hand along the sense of current, and you
Yes,
will
sir.
see where your thumb is going. Okay, where your
Pointing.
thumb is pointing or going. Okay, so
Yes,
just
sir.
see, just just curl your finger along the sense of current. Just do this and tell me the direction of the magnetic field you are getting. Curl your finger along the sense of current, you will find that the thumb will go away from you. So see the
Yes, sir.
current, that see the direction of current is this. Okay,
Yeah.
so when you will curl, the thumb will go away from you,
Away
away
from
from you,
me.
away from you or me means away from me or away from you. So you can say the direction is towards,
Outward.
no,
No, wait. Wait.
inwards, inwards.
Yes, inwards.
Direction will be inwards. Inwards means negative z axis.
Yes, sir.
Suppose the direction of current I am taking, suppose this is the circular arc, and in this circular arc, the direction of the current is like this. So can you tell me what is the direction of the magnetic field? This is the
Direction of.
direction of magnetic field. Just curl your finger,
Yeah.
cur-
Yes,
curl
sir.
your finger along the sense of current and see where your thumb is pointing.
It's inwards.
No, just curl your thumb along the sense of current. Just curl once.
Okay, sense of current.
Sense of current means the
Yes, got
direction
it,
of
sir.
the
It is.
inward or outwards.
It is out. It is along the. Wait, wait. It is
No.
outward, sir.
Yeah, you are doing like this now. You are doing like this. So your thumb is towards you now.
Yeah.
Your thumb is towards you. Towards you means outwards, and
Yeah,
away
it's
from you
outwards.
means inwards. Okay. So
Yes.
here you will get the direction at this point O, outwards. We have next. Now we will calculate the magnetic field at the center of the circular coil. Center of the circular coil. So I am taking one circular coil, and this case is very simple case. Just you can take this circular coil, and you already know this formula. Uh, this What is the magnetic field due to the circular arc? Mu naught divided by 4 pi
Mu not divided by 4 pi I d by r.
I alpha by r.
Yeah, I alpha by r. Sorry.
So r is the radius of this, and suppose the current is in this direction. Okay, and this is a circular coil carrying a current. Okay, circular coil carrying we have to find the magnetic field at the center. Magnetic field at the center. So now first decide the direction. What will be the direction? Just tell me. Why modified right hand thumb rule?
Yes, sir. Wait. Just a minute.
Okay, no problem.
It is inwards.
Yeah, very good, very good, very good. Inwards. Inwards. So this is clear, direction is clear, but now
Yes,
we
sir.
have to calculate. Now, can you tell me if you have this now? If you have this, suppose this is the uh, alpha. If this becomes whole circle, then can you tell me what this alpha becomes?
360.
Oh, very nice, very nice. Now this question has been solved. You will put alpha 360 degree, but always remember one thing. Always you will put the value of alpha in radian.
Yes, sir.
Alpha you will take in
Radian.
radian. Always. So
Yes.
just a minute. Okay, here. So alpha here this time will be 3. Alpha is 360 degree, and we have to convert this 360 degree into radian. So what we will do, if you want to convert from degree to radian, so what you should do, you should multiply the angle with pi by 180 degree. Then okay, pi by 180 degree, then you will get 2 pi. Okay, suppose you want to convert 60 degree into radian. So what you will do, you will multiply this 60 with pi by 180. So what you will get,
Yes.
you will get pi by 3. So accordingly you can get. So alpha in radian you will get 2 pi. And what you will do, you will just put the alpha here. So your magnetic field will be mu naught divided by 4 pi. I alpha is 2 pi divided by r. And this 2 pi is cancelled with this. So you will get mu naught I divided by 2r. This is the magnetic field at the center of the circular coil carrying current. Magnetic field at the center of circular coil carrying current. So this is the final answer.
Correct.
See how easily we have
Yes, sir.
calculated. I have just used this formula. This is the general formula, you can say. Okay.
Yes, sir.
So just you can note it down.
Yeah. Yes, sir.
And alpha is what will be the value of alpha in semicircle?
Semicircle, sir, 180, right?
Very good. So I think that case you should solve by yourself. Means you will put the alpha as 180 degree in this formula.
Yes,
This is
sir.
the magnetic field at the center of a circular arc sustaining an angle alpha at the center.
Yes. Can I scroll down, sir?
Yeah. So these are very simple cases that we are discussing. Okay. So for the semicircular coil,
Done, sir.
okay, good. Now we are moving towards this. See this? This is the magnetic field at the center of semicircular coil. Okay, magnetic field. Write the
Field at
heading
the center
magnetic
of
field at the center of
semicircle.
semicircular coil. So I
Yes,
am
so we'll
taking one
just put
cell.
the value 180, right?
So I am value of alpha
Sir.
180 degree, but you should put in the radian.
Yes.
Is your internet connection okay?
Yes, sir, it's okay.
You can check.
Just a minute, I'll check, sir. 1 minute. Sir, it is okay, sir.
Okay, na? Okay, no problem. So here, Just a minute. Taking a circle, and I will convert this circle into semicircle. So this is the semicircle. Now just this is at this center point, and suppose this is A and this is B, and this angle alpha is equal to 180 degree this time. And when you will convert this 180 degree into radian, then what you will do? You will multiply 180 with pi by 180, and you will get pi radian. You will get pi radian, and you will put this value in this formula. And remember, I current is flowing here. I current is flowing here. So just put the value and get the answer.
Yes, sir.
I
Yes,
and
sir.
instead of alpha, just put pi. I into pi divided by r, and this pi will cancel out, and you will get mu naught I divided by 4r. So this is your final
Yes, sir.
answer. Just note this one. And for the direction of the magnetic field, what you will do? You will just curl your finger along the sense of current and tell me the direction. Inwards or outwards?
Inwards.
Very good. Now I think you have understood. Inwards is representing by this. Just copy this, then we will solve the numerical.
Just yeah. Just a minute, sir.
Okay, no problem. Harsh, on Friday, are you free on this Friday?
Like tomorrow?
Tomorrow?
Yes, sir. Tomorrow I'm free.
The thing is that the system is not working properly. So I am thinking that I should leave this class 15 minutes before, because I have to take another class also.
Okay.
If I will take that,
Okay.
Okay, we will just discuss. So,
Sir, you can take the class tomorrow, no problem.
I can take your class tomorrow for half an hour, or maybe for one.
Sir, half.
For 1 hour, can I take your class?
Sir, you can take for 1.5 hours.
Okay. Means you are
You
ready
can take
for that?
1.5 hour also, like same time, 5 or 6. What, sir?
Means you are ready for that?
Yeah, I'm ready. You can take for work. Yeah, you can take 1.5 hour also. You can take, so no problem.
Okay, no problem. Okay, if there will be the class tomorrow,
Sir, you
then
can just message me. I'll tell you.
yeah.
Sir, same time also you can keep.
Yeah, same time. What the time you like? I am not adding the time by myself.
Sir, like 7:30 to 9 or something like that.
Of course.
Done, sir, done.
Done, very good. Now direction you have calculated. Now we have some questions. First question is this.
Okay.
See, this question is very, very simple.
So
Here
just
in this
write
question,
this question.
you can write this question first, then we will solve. This question is very simple question.
Yeah, just a minute, sir. Yeah, I can see that.
Yeah.
Done, sir.
Done. Very good. Now, so just see here. Just 1 minute. Okay. So Harsh, see this. So what you will do, you have a wire like this. See, you are seeing this wire. Okay, you have a wire like this. So what is happening here? For solving this question, and what is the question? Means you have to calculate the magnetic field at this point. Okay, okay, you have to calculate the magnetic field.
Yes, sir.
Just see this. So what we will do, we will just divide this wire into 3 parts. One part is this, second part is this, and third part is this.
Yeah.
Third part is this. Now. So now let's see. For the first what we will do, first we will calculate the magnetic field due to this first wire at this point O, second wire at this point O, third wire at this point O. Now
Yes, sir. Fine.
this first wire is the straight wire. First wire is the straight wire, and for this straight wire and this point, for this straight wire, this point O is lying on the axis. And I have told you, in case of straight wire, if a point lying on the axis, the magnetic field at that point is due to that wire equal to 0. In the starting,
Yes,
just
sir.
I am showing here. Just I am showing. See here. Not this point. This point is I have told you. See the magnetic field. This is a point on the axis, so magnetic field is 0 here. Fine now.
Yes, sir.
So I think that is okay. And this is also this is true for the wire number third. This point O is on the axis of this wire. So due to this wire, the magnetic field at this point O is again 0. So V3 is again equal to 0. So total magnetic field at the center due to will be only due to this wire segment number second. Okay. So what is the formula for the semicircular wire? Magnetic field for the semicircular wire? Mu naught I.
Yeah, mu naught I. Magnetic field semicircular wire mu naught I. Mu naught I by 4 pi. 4 R.
Yeah, very good. Mu naught I by 4R. Now this question has gone. This is, and you will calculate B2 mu naught and current I divided by 4, and suppose I am supposing A is the radius of this, so for A you will write. Okay. Now what will be the direction? Can you tell me the direction? Just simply just apply right hand, modify
Direction.
right hand. Inverts. Direction will be inverts. Okay.
It's inverts, right? Inverts.
Yeah,
Yeah, inverts. Yes.
So when you will calculate this, you can write this as this. This is magnetic field at point O. Total magnetic field at point O is equal to V1 plus V2 plus V3. Okay. I can write this now in the vector form. So magnetic field at point O. This is the total magnetic field I am talking about. Okay.
Yes.
So
Yes, sir. Yes.
this is equal to V1 is equal to 0, and this V2 is equal to mu naught I divided by 4A, and this is inverse. So for inverse, which unit vector we will use? Minus K cap.
Minus K cap. Yes, sir.
If we are writing in the vector form, and this is V3, this is again 0. So finally you will get your answer. V this is equal to mu naught I by 4A, and this is minus K cap. This is your final answer. Just note it down, and then we will meet tomorrow at the same time. Okay.
Okay.
And
Yes,
we will
sir,
have
yes.
a class of either 1 hour or 1.5 hours.
Okay. Okay, so done, sir.
Okay, completed now?
Yes,
Harsh,
yes.
completed the whole question. Means Harsh, how I have written this, are you getting? Means magnetic field
Yes, sir. Got
is
it,
the
sir. Got it.